Elon Musk has yet again sparked debate by asserting that solving our energy problems may be simpler than it seems. He proposes the construction of new nuclear reactors and the reactivation of those that have been shut down for political reasons. This prominent entrepreneur, along with other industry leaders, supports the scientific consensus that nuclear power is crucial for meeting future energy needs sustainably and with lower carbon emissions. Moreover, Musk has recently introduced an innovative solution. Will he move away from solar energy? We'll find out in the upcoming video. Stay tuned for every update. Nuclear energy, focusing on fission. 2 years ago, at the BW event hosted by the Crypto Council for Innovation, Tesla and SpaceX's influential CEO discussed Bitcoin mining. He advocated for nuclear energy as a means to make it more efficient, highlighting that nuclear power is clean, emitting no greenhouse gases. Despite incidents at older nuclear facilities, Musk believes in the safety of modern nuclear plants. Nuclear energy can be made extremely safe, focusing on nuclear fission. Nuclear fusion isn't a necessity, Musk stated. Nuclear fission, the primary process in traditional reactors, occurs when a neutron strikes a large atom, splitting it and releasing energy. Fusion, on the other hand, merges light atoms to form a heavier one, also releasing energy. Musk explained, the sun is a natural fusion reactor. Fusion is considered safe as it doesn't produce long-lasting radioactive waste. However, current technology faces challenges, such as consuming as much energy as it produces. Several companies are striving to make fusion energy commercially viable without success so far. Musk has consistently supported nuclear power, though he hasn't elaborated on ensuring plant safety. In a 2007 interview with PBS, he suggested investing more in nuclear plants. It's more efficient than coal or natural gas plants, he said. Nuclear energy accounts for about 20% of the energy produced in the United States today. Conventional nuclear plants have evolved. TerraPower, founded by Bill Gates, is innovating in traditional nuclear technology. Despite this, nuclear energy remains controversial. Critics advocate for expanding renewable sources like wind and solar, considering them safer. Musk points out the growing interest in smaller nuclear plants. Companies are exploring small-scale modular nuclear reactors for various industrial applications, including electricity generation, mining operations support, and providing heat for industrial processes. Modular reactors are seen as viable for small settlements, especially in rural areas, and even to power ships. The innovative small modular reactors, SMRs, can produce up to 300 megawatts, about a third of conventional reactors. They significantly generate low-carbon electricity. Being smaller and modular, they are easier to assemble in factories and transport for installation. SMRs use nuclear fission to generate energy. The energy of the future. Small modular reactors, SMRs, boast an innovative compact and modular design, intrinsically linked to numerous advantages they provide. One such advantage is the possibility of installation in locations where larger nuclear reactors would be impractical due to their reduced size. Additionally, compared to large-scale reactors, SMRs offer greater construction economy because their units can be prefabricated, transported, and assembled on the intended site, whereas larger reactors often require custom construction, potentially causing delays. SMRs are notable for their swift construction and the ability to be deployed incrementally, aligning with the steady growth in energy demand. They are particularly useful in challenges such as limited electrical grid coverage in rural areas and the high cost of connecting these areas to electrification. The maximum recommended capacity for an individual plant in the grid is 10%. With their smaller electric capacity, SMRs can be integrated into existing networks or operate independently, providing sustainable energy for industries and communities in locations without adequate transmission infrastructure. A subset of SMRs, microreactors, are crucial in this context. Designed to produce up to 10 megawatts of electric power, microreactors have lower emissions compared to other SMRs. They are ideal for areas lacking access to clean, reliable, and affordably priced energy. They can replace diesel generators in remote locations, such as rural villages or businesses, or serve as emergency backups. The designs of SMRs are generally simpler than those of conventional reactors. Their safety often relies on passive technologies and inherently safe characteristics, including low power and operational pressure. Passive systems use natural physical processes, like natural circulation and gravity, requiring no human intervention or external energy to shut down systems. In some cases, these wide safety margins could significantly reduce or eliminate the risk of accidents involving radioactive release. SMRs use less fuel compared to conventional plants, which need refueling annually or biennially.